Hello everyone, myself Pansai Srinivas. I am from CSIT B section. My roll number is 33C7. My topic is about automobile part tracking with uncertain disturbance, a dynamic game approach, which interacts with the automobile tracking of distributed systems with using a dynamic game approach. To the topic, introduction to the part tracking in automobiles. Part tracking is an essential for autonomous vehicles, navigation, and safety. Uncertain disturbance such as winds or road irregularities complicate the control process. A dynamic game approach offers a robust framework to address these challenges effectively. Motivations and objectives. Improving the path tracking accuracy under certain disturbances is a critical goal. Existing control methods often lack robustness against unpredictable external factors. This research aims to develop a control strategy based on dynamic game theory to enhance the robustness throughout different factors such as um, irregular roads or any other natural calamities. Challenges in path tracking with the disturbances. Uncertain disturbances can lead to deviation from desired tragedies. Traditional control methods may not adapt quickly to changing external conditions. If there any obstacle suddenly occur, they cannot be tracked through these systems. Ensuring the stability and safety under disturbances required advanced control strategies by processing the fields. Overview of dynamic game theory. And dynamic game theory models the interaction between the vehicle and disturbances as a game. It considers the worst case disturbances scenario to optimize the control actions. This approach provides a systematic way to handle uncertainties in control design by analyzing the norms and terms throughout the section to design a map or a graph to reach our destinations without any disturbance. System modeling. The vehicle dynamics are modeled using nonlinear differential equations. External disturbances are incorporated as uncertain inputs within the model. The control objectives are to minimize the path deviation and control effects simultaneously, like shipping system and accounting system, online store and admission store. They both interact with the inventory database and navigated to the payment system. Formulation of dynamic game. The control problem is formulated as two-player zero-sum game between the vehicle and disturbances. The vehicle aims to follow the desired path while disturbances attempt to deviate it. The solution involves finding a stable point that guarantees robustness. That means a project space, profile space, select a profile, the simulator, play off the data, and a empirical game analysis. Control strategy design. The control law is derived using Hamilton Jacobian Isaacs equation. This approach ensures the control is robust against worst case disturbances. The controller adapts in real time to disturbances and maintaining the trajectory occurrence to reduce the disturbances. Numerical solution approach. Solving HIG HJI equations directly is computationally intensive. That means it can be difficult to solve the equations with a normal conventional intention. Approximate dynamic programming techniques are employed for feasible computations. Discretization of state and disturbance space facilitates the numerical solutions to reduce the impacts. Simulation setup. A typical vehicle model is used for simulation incorporating realistic dynamics. External disturbances are stimulated as uncertain, time varying inputs. The desired path is predefined trajectory such as a limb center line. Performance matrix. Tracking error measures the deviation from the desired path. Control effort evaluates the energy used to maintain the tragedies. And robustness is assessed by the system ability to handle varying disturbance levels across different ranges and distributions among the matrices values to perform the optimized way of trajectory. Simulation results without disturbances. The proposed controller maintains the accurate path tracking in ideal conditions. Deviations and minimal demonstration baseline effectiveness. Control input remain within practical limits for nominal scenarios. May be eligible for this factor. Simulation results within uncertain disturbances. The dynamic game approach significantly reduces the tracking errors under disturbances. The controller effectiveness counterattacks the external influences to stay on the path. Results outperform traditional controllers that do not account for uncertainties, like this graph which has shown the uncertainties. Comparative analysis. Compared to PID and LQR controllers, the game based approach offers superior robustness. The control law adopts proactively to reduce disturbance challenges. These methods enhances the vehicle safety and reliability in unpredicted environments. Advantages of dynamic gaming approach. Provide a worst case optimal control solution considering uncertainties. Ensures the system stability and safety under a broad range of disturbances. Facilitates the systematic design and analysis of robust controllers across the game. Limitations and challenges. Computational complex can be high, essential for real time applications. Model accuracy impacts the effectiveness of the control strategy. Extending the approach to high dimensional systems remains ongoing challenge, which may be various to the different terms and technologies. Future research directions. Developing more efficient algorithms for solving HIG equations in real time may improve the effective resilient distribution system. Incorporating real learning based methods to adapt to high dynamic environment. Extending the framework to multiple vehicles. Coordinating and cooperatively controlling. Practical implementation enhances the robustness of the autonomous vehicles in real world scenarios, contributes to safer and more reliable autonomous driving systems, facilitates the compliance with emerging safety standards and regulations to improve the non-disturbances activities to across the challenges. Conclusion. The dynamic game approach effectively addresses the uncertainty disturbances in the path tracking. Simulation results demonstrate the improved robustness and accuracy. This methodology offers a promising direction for advancing autonomous vehicle control. throughout the secured lanes. And the summary of a key contribution: formulation of a robust control framework using dynamic game theory is a very tough situation, and development of a numerical solution approach for real-time implementation is another key contribution. Validation through comprehensive simulation under various disturbance conditions is another achievement through these key contributions. Thank you for giving this opportunity for tell, uh, telling about the dynamic game approach for reducing the any accidents.